Good morning, and Jawan. My name is Donghee, and I'm very happy to be here at PyCon Taiwan 2025. And my name is Donghee. And today I'm going to talk about the CPython past, current, and futures. So let me introduce myself. I started software development from 2018, and I'm working at Keynote from last year. And I started to contribute to CPython around 2017, and I've become Python Core Developer from 2020. And I'm serving as the Python Student Council member this year. Yeah, so yesterday topics is all about AI, and in the AI era, Python is most popular language in the world and widely used. But it means that Python need to take a more responsibility for this era. But in this era, like we have a benchmark, and if you see the benchmark numeric, that the C and Rust is closer to 1.0, Java is around 2, but Python is over 75. So natural question will be why Python is so slow. But if we compare to Python to between C and Rust, the implementation Python is based on interpreter, and the Python itself has a dynamic type language. So this characteristic itself is very challenging these days. So we will take a look at how we solve this issue. So today talk, I'm going to explore the basic CPython execution pipeline, not too deeply, just simple one. And then we will take a look at the past attempts and current attempt for those to make a CPython faster. And then next topic it will be about gear. So we will take a look at what is the gear and what we did attempt for removing the gear from CPython, and then the status of free-threading. And then I'm going to talk about what can we take a look at for the future of the CPython. Let's take a look at it. So this is a very basic pipeline of the CPython. It's just for tier 1 interpreter, and tier 1 interpreter has a 5-page for execution of the Python bytecode. The first page is maybe a parsing. This parsing is tokenize the Python and make a construct to AST to analyze the CPython code. So once the AST is construct, the AST has include more information that the interpreter should know. So theoretically, if once you construct the AST, then you can also generate the bytecode directly. But CPython has a more optimization path for making a CPython faster. So we have a more page like we call it control flow graph. Flow graph is kind of the sequence of instruction we call it basic block. This control flow graph has information that how the Python loop is executed, which bytecode is jumping in, or what's the stack depth of each node. So we have more information of this control flow graph of CPython. Then we can also remove the unnecessary bytecode instruction we call eliminate unreachable instruction, or we can make a people optimizer in these pages. So once we finalize the optimization in the control flow graph step, then we can generate a bytecode, and this bytecode is based on stack machine. So once the bytecode is generated, the CPython execute the bytecode with the stack. So once the bytecode is pushed and it's pop, so every instruction have a own reference count, and we did everything during the stack machine. So let's talk about why is CPython slow again. The CPython is basically a stack machine based interpreter without jitter, unlike Java. And there was no optimization pipeline for bytecode execution. We call it specialized interpreter until Python 3.11. And as you know that the CPython using a reference counting for managing the Python object, but this is a very painful execution point. So if we remove the one reference counting operation in the CPython, we noticed that we got a 10% or 20% gain of performance enhancement. And another issue is that we have a C API for CPython, but this is very difficult to optimize because it exposes too many CPython implementation details. So this kind of issues are why can be explained why CPython is slow. So let's take a look at historical review, how we try to make the CPython. The major two approach of making a CPython faster is re-implement CPython from the scratch. And the other approach is like just fork the CPython and modify their CPython for their workload or implement their JIT. So the good example is for making a CPython implementation from scratch is PyPy. And these days, like the forking the CPython is one of the popular ones, maybe a Cinder. So if we take a look at PyPy, they use the from the scratch approach, and they build their own tool based on they call RPython. It's very similar to Python, but it's slightly different with the Python because it's more like C-like DSL. And once they write a virtual machine with the RPython, they can generate automatically virtual machine and JIT compiler. And they also use the JIT. They also implement a JIT implementation they call meta tracing approach, and this is very successful approach to make a C basically like a Python faster. But they has an issue for their own self because like they have a difficulty to make a C extension module that are widely used in a CPython with a compatibility issue. So even they make a Python faster, but for emulating the behavior CPython, the sum of the code path is very slow. And another approach that they to make a Python faster is that tried by Google is we call on-route throw. They forked the CPython and they used the LLVM at the time, and because like at that early 2010, LLVM is rising very popular compiler framework that make everything can make a fast. They just try, but yeah, as they said, like they need to use a high level knowledge for making a Python faster, but the support of LLVM is not enough. And they said also that most of Python code at Google was not that performance critical. So like I think that their sponsor was not sustainable. And 2014, the Dropbox also tried to make a CPython faster. They used the from scratch approach. They re-implement everything with a C++. And they also use the multi-tier approach that have a interpreter, baseline JIT, and LLVM JIT. And I thought that they catch they enhancement a lot of Python performance, and they catch up a lot of compatibility issue. But the problem was that the Python version 1 was based on Python version 2 and Python 2, and at that time is transition era that from Python 2 and 3. So the Dropbox decided to drop this project at the time. And later, 2021, the Cinder, this is the fork approach. Like the Instagram, they fork their CPython for their workload, and they apply several optimizations approach, including immortal object, and even some of feature like immortal object is they also send to the CPython upstream. And they also use the multi-tier execution pipeline like Python version 1. They provide bytecode execution, high-level IR, low-level IR, machine code optimized pipeline. And they also provide static Python feature. Like it's very similar to MyPyC or Cython, but it does not need to pre-compile. It can be just run a runtime without any compilation. And they also report that they show that from 20 to 30% performance enhancement their workload, and I think that this is very successful project, and they are still going on. And if you will be surprised that there is also Python version 2. The people from Python version 1 left the Dropbox and they set up their own startup and they launched the Python version 2, and they use a different approach. They fork the CPython, and then they write a low overhead JIT with a dynamic assembly library. And they also use the LLVM board to optimize their build. And they also provide a Python write for programmable JIT for CPython. And I think that this was quite a successful project, and they even exit their product to Anaconda. But I think that they did not keep maintaining currently. And they used the LLVM board at their project, and they also sent a patch to CPython upstream, and so you can still use the LLVM board in a CPython. And if you use it UV, then the in Python installed UV is using this LLVM board optimization. So let's talk about why the cost of the data of Python implementation. Like the first problem is it's very difficult to keep up following the latest CPython implementation. Like once you start to making a CPython faster in Python 3.10, and the next year the CPython releases a new Python 3.11. Well, the many things have changed, many bytecodes changed. So they also have a difficulty to follow up, and it still has an issue, even the Cinder team. And then once you make a CPython faster, you should consider about the behavior, the compatibility, because of different behavior between the CPython. And the problem is that the meaning of using the CPython means that using the NumPy or Fast API or Django, like people just want to using the popular framework, but they depend on many C extension modules. So, but they have a difficult. And the other problem is it's the most common problem for most open source project, but it's this lack of resources for funding or contributor. Like you should take 8 hours per day for this project, but it's very difficult. So many people think that. So what's the solution then? CPython team said like, why not we just make a CPython faster? So maybe X and current Microsoft team and community contributors start to making a CPython faster. And we focus on improving the bytecode interpreter, and not just for improving runtime. And we expect that we can make CPython make a 500% faster than Python 3.10 in 10 years, 4 years. And Mark Shannon read this project based on his PhD paper, and this project was very great because in the past we also tried CPython faster with the optimized runtime, but it's just like feeling. Like if you use this technique, it could be faster, but it's not true. So the Mark Shannon run the benchmark and the analysis which kind of bytecode is bottleneck, or which kind of bytecode should be faster, and then he improved the interpreter based on specialized adaptive interpreter. So as the result, I think that CPython is become a lot faster. But if you expect that the Python or C extension be faster, it's not. But the pure Python become faster, and I/O bounded task is also not enhanced. But the execution of pure Python codes become faster. But in this year, unfortunately, the day before PyCon US, Microsoft said we will not continue to support the faster CPython. But CPython core team is focusing on to migrate project from Microsoft to community-driven project. And one of the tasks we are doing is migrating benchmark infrastructure they own to Python core team. And we also had a bi-weekly meeting called CHIPS, like CPython hacking interpreter and performance sync. And you can see the people in here, including me, Kenjin and Mike, Barry, and Mark Shannon, and Diego, and Thomas Warrow from Meta. And we discuss a lot of things for how we can make a CPython faster. Or we even talk about free-threading and JIT. So if you worry about that, the CPython will not be faster, I think that we will continue making a CPython faster. Yeah, let's talk about gear. I think that my talk is a little bit faster than I expected, but let's just enjoy. So how many people actually show that when was the gear was introduced? In my slide, I attached a link of the gear, and you can just scan this QR code, then it will link that the first gear was introduced. The gear was first introduced in 1992 August 4th, just after I born after 8 months, because I born on January 5th in 1992, and the gear was introduced because when the threading module is introduced, they have to make a thread safe for reference counting. So the reason the Guido choose the gear is it was very easy to implement. Is that true? And then you have to think that when was the 1992? If you see the graph, at the 1992, the most of core is just one. At that time, they did not expect that the multi-core era is coming faster. And one of the good points of the gear is that it does not require many overhead. And the point of the gear is that how we can manage the reference count of the Python object in a thread-safe way. And if you take a look at the CPython code, there's a very difficult and complex C code. But if we choose the gear, you don't have to think about too much about deadlock issue or race condition issue of reference counting itself. But there's also the limitation of the gear. If your workload is IO bounded, then it will be fine, because most of threads are actuating the network workload. But if your workload is based on CPU bounded, it will be terrible. It will be bottleneck. So in the AI era, most of the workload is CPU bounded, so it will be a significant issue at these days. So everyone know about PAP 703 these days, but the removing the gear is not just burst approach. The PAP 703 was not burst approach. In 1996, the Greg Stein first attempt to remove the gear, we called free-threading patch. It used the mutex log around the PyEncrypt and PyDecrypt. This is a C API that is increasing the reference count and decreasing the reference count. But the result is not good. It's nearly twice slow. So if you want to take a look at the patch, you can just scan the QR code. And also Guido also write an article about this. And if you want to take a look at deeply, you can just click the link. And 2000. Sorry. Anyway, so PyPy is also tried to remove the gear we call software transaction memory (STM). Led by Armeringo. They tried to run a multiple thread in a parallel transaction concept, and it was fast than CPython. But the important thing is that how will it be slow than baseline? So baseline in this case is not PyPy. It should be it's PyPy, not CPython. So the result of PyPy STM is that is 25% to 50% slow down. So it was not acceptable at that time also. And then later, 2016, the Galactomic project was launched by Larry Hastings. And he also tried to remove the gear. He used the fine-grained locking, atomic reference count, and buffer reference count. But it was also slowed down, 3.5 slower in the work clock time, 2000% of slowdown in total CPU time when you compare to baseline. This baseline is based on CPython. But the Galactomic project leave the benchmark that what is the important North Star metric for the removing the gear. So later we used this the Galactomic project benchmark to verify the PAP 703. And so there's a 3 trials to removing the gear in the past. So people think that is this possible? No. So we think that the ultimate solution to remove the gear might be not using the reference count and then just moving the tracing GC. But is it not also a simple issue? Because if you remove the reference count and then using the tracing GC, it means that it will change the life cycle of the Python object. So it will be the Python object can be deallocated then on unexpected timing that if you depend on the behavior of reference counting. So, but even though there are several trials to adopt tracing GC by using the libgc or the Google's project called name Python Safe Thread, but they did not success. So we thought that, okay, so thread is not solution. So let's think about different way. The other approach was the sub-interpreter, led by Eric Snow. The concept of the sub-interpreter is that if the one main interpreter can spawn the multiple sub-interpreter that are based on multiple threads, that could provide real parallelism in a thread with threading using a thread resources. So Eric Snow started this project from 2017, and this project also improved the isolation of each module to be thread safe. But this project has also limitation for sharing the object, and we also tried to solve this issue. And if you are using the Python 3.14 this year, you can just use the sub-interpreter feature that provide a real parallelism, even the gear build. So if you're using the gear build and if you need to use a real parallelism in the gear build, you just try this interpreter pre-executor. It will provide real parallelism in threading resources. And 2021, yeah, like Sam Gross sent one mail to that. He successfully removed the gear. And I think that the actual reaction of the most core dev is that we cannot believe it, but his success. And one thing I want to share in this topic is that we don't use that term name no gear because because no gear looks so little bit weird. So if we no gear, it looks like S gear. So we decide to use the free threading. So let's just using that term, that free threading. The key concept of the free threading is that the most of the objects are actually owned by and managed by the single thread that are created. So if we consider that the most objects are mutated by the owner of the thread, then they can just use the fast path reference count called name local reference count. And if that object is shared by other threads, then they can just using the shared reference count, but that will be a little bit slowed down. So free threading project just using two approaches. One is the bias reference count, and the other is the default reference count. And if the object is shared too much, like for example, code object, top level functions, modules, then they delay to calculate reference count in the GC time. So that's how we can overcome the performance issue of with the removing the gear in the CPython. So if I share the current pages of the free threading project, we separate the 3 pages: so page 1, page 2, and page 3. Page 1 was just for experimentation, like can we really implement the free threading CPython in our CPython code base, and we success. But it was just experimental. Like it means that it can be dropped anytime if you want. But we thought that we reached the goal that it is sustainable project. So a few months ago we declared that this free threading project is now in page 2, called PEP 799. So the PEP 7, the free threading project is not more experimental project. It will be the official support by this Python core team from now on. And if we achieve the more goal during the page 2, then we can declare the page 3, and it means that the free threading project is now default. So the goal of the page 2 is, like, as I said, no more experimentation project, and we're going to provide the stable ABI for free threading. The current status of the free threading, we does not provide the stable ABI. It means that you need to compile every C extension for every release, but it's very burden for open source library maintainer. And from now on, like if someone wants to propose a new experimentation project for CPython, like if someone wants to, like, I want to make a green thread or G event in a CPython, then the project should be compatible with the free threading project, and not just for the gear build. And we also goal that the free threading project should be slower in a 10% performance degradation. No more above is not reverse active. And and memory usage should be increased under the 15% if we compare to gear build. But I think that we are currently keep this guardrail in this moment, so just less using it. Yeah, so let's talk about future. So nobody can expect at this moment, but who knows? But there are many topics that can be discussed. One is maybe a JIT and progress JIT and virtual thread. And the current experimentation project called name copy and patch JIT is very interesting idea, because like they define a tier 2 interpreter. The goal of a tier 2 interpreter is like transform the tier 1 bytecode in the micro opcode, and then they analyze which bytecode can eliminate that unnecessary code inside the bytecode. And once they optimize the tier 2 micro opcode, then they compile into the machine code by using the LLVM. But this is a little bit different approach that they are using before. So if you have an interest in this approach, you just find out a copy and patch JIT. It's kind of pre-compiled JIT so it does not require any runtime calls during making a machine code. And another idea is maybe progress JIT, because like even this time, like there are many projects that are start to making a JIT for CPython, and if you know that even the PyTorch have their own JIT for making the PyTorch faster. So there's many JIT that can be implemented for their workload. So why? Let's think about how we can install the JIT like through the PIP, like PIP install XJIT or PyTorch JIT, Cinder JIT. It will be amazing, because like even if we success to implement the copy and patch JIT, it will not work for our workload. So you can choose the specific JIT if you want. So we discuss about like how we can provide the interface for the JIT implementation paper. And last topic might be a virtual thread. Like definitely like Java, Java already showed that the virtual thread is workable. And this year, Blanky Summit, the Mark Shannon also shared about the idea of a virtual thread. So I think that if we success to remove the gear in the free threading, but it also limited to just use the system thread. So, but if we can adopt the virtual thread, then we can provide more parallelism than we can do that this moment. So, but nothing is decided at this moment. So let's just take a look at. So that's my keynote today, a little bit faster than expected. And one thing I want to share is like, if you want to support this amazing project, just become a PS member and sponsor PSF. And that's all. And if you have a question, you can just ask me. And even after keynote, I will work around nearby. So just ask me. Thank you.
Okay, thanks, Donghee, for his wonderful presentation. Now let's switch to the Q&A part. So first, can you share the pros and cons of the faster CPython project maintained by company versus maintained by the community?
Okay, so it's good thing that if the faster CPython driven by communities, that we don't think about too much about sponsor, and that's good thing, because sponsor want to, they have their own timeline, so maybe we could be too urgent for decide something. That's good thing. So we can decide a good solution with enough time. But definitely the bad thing is that like making a CPython it needs a lot of money. Like if you may need the infrastructure to measure the benchmark accurately in a clean room system. So if we need fund, like we need to find a fund to sponsor this project. So that might be bad thing. Yeah, but I think that's not that difficult to continue that driven by community, even if there are some cons in this way.
Okay, so the second question is about, in the free-threading model, how do you decide when an object is used in multiple threads too much to switch to the cross-thread reference count?
So it means that how we decide that this object is mutated by multiple thread. If I understand correctly, like it's kind of like, I think this is kind of observation based on benchmark. Like we just observe that the several object is too mutated by multiple thread, and then we decide to making more like this object should be immutable, or this object should be using the delayed reference count. So it's kind of heuristic maybe. So I think that this would be our answer.
So next question, what types of workloads truly benefit from the speed up of Python?
So maybe two use case. One maybe is faster CPython. As I mentioned, that if your logic is based on pure Python, then the faster CPython definitely benefit for you, even for JIT. And free-threading is like if you depend on just a thread-based workload, or even you using the process-based on workload, you can switch to the thread-based workload. So that will be a benefit. Yeah.
Okay. Next one, do all these performance improvements make the CPython implementation harder to work with for the core developers?
Yes, definitely. I believe that everybody was worried about that the difficulty of maintain of the CPython code base these days. Like we said in around this Python 3.9, we said that CPython code base is very easy to maintain by a single man. Like even if our core dev left the CPython, like Guido can maintain the CPythons by himself. But nowadays they have too many features that too many knowledge need to understand the CPython code base, including DSL or complex reference counting management. So that is definitely true. But we try to make a resource to understand what kind of knowledge to maintain CPython code base. So we try to solve this issue every year.
Okay, next one. As a Python developer, is free-threading changing the way we code? Like we have to care about the thread lock, race conditions, and third-party libraries.
Yes, so there is a true and right of that. We don't have to care about too much about the race condition in Gearbert. Like if your workload is based on IO bound, then you still use the mutex or lock for pure Python code, because like they have a timing issue. But most of people don't care about this. But so it means that if we use the free threading by default, it means that all your thread workloads should case of a mutex or lock. But we try to make a Python object as thread safe as possible. So for example, tuple list dictionary are thread safe, but it does not mean that it is faster in your single thread workload. So if you consider to using the dictionary or tuple for your free threading, your multiple thread environment, maybe you should consider another faster concurrent data structure for your workload. And we know that the several people are prepared for providing a concurrent package for those use case. So let's just wait it. Yeah.
How does the CPython core dev team collaborate? Since everyone is in different time zones, I can imagine maybe it's not easy to find a time that fits everyone.
So yeah, it's everybody at different time zones. So like, so just for example of student council, like I stay in Seoul, and the one other people stay in London, and the rest of people are staying in the US. It means that we call that's triangle time zone. So nobody's satisfied the time zone. So we just are bidding early morning or early night for someone. So, but we try to make everybody be happy. So, yeah, so there's no good solution for this. But except the sync meeting, we just using an internal Discord, so we can just discuss something asynchronously, and if we need something mid, then we just make a time zone. Yeah.
Yeah. Next is also an interesting one. The rumor has said we might have some Rust in CPython. Is it true? And what could be potential impact? Will they make it Rust Python?
Yeah. So. Yeah, rumor. Yeah, rumor. It's rumor. Yeah. So like one thing I want to say, like I really love Rust, and I have a experience to contribute to Rust Python itself because one of the maintainer is my friend. So I really love Rust, and I still recommend to using the PyO3 if you want to make a new extension module for CPython. And that's true that some of the Python core devs want to write a C extension module based on Rust. That's true, but there's also limitation of Rust itself. Like I know that Rust is very memory safe. It's very good at memory safe, and you don't care have too much of thing about race condition. But the main problem is that this Python is too widely used. It means that the Python is not just only run in x86 Linux server. It's also run at like IBM something workstation. I didn't never watch it, but the coverage of the C compiler, including with the Clang and GCC, they cover all of the platform they can cover. But since the Rust is based on the Clang, this is very limited. And the other issue is that the Rust does not provide the stable API from the language itself. So at this moment, I think that there's low possibility to adopt Rust. But like if some feature does not need to provide our platform, this is my personal opinion. But like if we think about JIT, like JIT is not that essential modules for Python. Then how about we can write a JIT with Rust? But this is like just my opinion. So in conclusion, yeah, there's no concrete discussion to adopt JIT Rust in CPython, but like some people just try to using it. So let's just wait. Yeah.
Okay. So could you compare the JIT between PyPy and CPython? Like how is the core PyPy team involved in CPython's development?
Yes. So the relation between PyPy and CPython is very complex, and I think that the PyPy team is very good at explore the academic approach that how we can make up Python faster. And these days, even PyPy team also send a patch to us like that if that their technique is acceptable in CPython, they send a patch. So one of the module introduced by that in last release that the PyRapper is actually start from PyPy project. So that might be one result that the collaborating between the PyPy and CPython. And even if the JIT and the other making of Python faster, they also jumping into the discussion that they observed in the past. So that's how we collaborate with the PyPy team.
Next seems to be an extension from the panel yesterday. So does the CPython core dev team use AI tools like Gemini or Claude for developing? And is it helpful for this kind of use cases? Yeah,
so it is true that this is a very rising topic in a CPython core team also. So like I also use the Claude code in my company, also in my open source project. But like current LLM is very good at understand why this code is written in this way. But like writing a CPython code is like is solving the unreference. There's no reference for this problem. That is the biggest problem in a CPython. Like if you make some progress in a CPython as a dynamic type language, you can just share the new paper to some academic submission. So the truth is that Claude and Gemini is currently not good at solve the new issue in a CPython, but it helps to understand why this kind of code is written. But the other side about the platform or toolkit for CPython, like let's think about we have to maintain the benchmark shoot for the CPython. Then we currently using the Gemini or Claude. Maybe last month, like Pablo also shared the memory.python.org that is measuring that measuring the memory overhead in a free-threading and default build in CPython, the most of the code are actually written by Cloud Code, and that might be one use case that we are using it.
So how is being in the steering council help you holistically understand CPython's future?
So what's the holistically?
In a big picture, or
yeah. So yeah, that's true. That like before I become a steering council member, my topic is very limited. Like I just have interest in like self-interpreter or faster CPython or free-threading, but the other topics like typing or packaging, I didn't have any interest. But like once I become the steering council, I have to read bunch of PEP every week, and I have to decide something. I cannot say I don't know. So I also asked sometimes the ChatGPT that what this PEP means. So, but eventually, yeah, the activity of steering council definitely increased my knowledge about CPython, and I think that this is one of my growth in this year.
So how long do you think it will take to have the entire ecosystem to support free-threading CPython and get rid of the Go version?
Yeah, it's nobody expected like we experience Python 2.3, but I think that we feel a different atmosphere than 2.3 because like it looks like the removing the gear is like over 20 years stream of all Python users. So many library maintainers actively try to support the free threading in this year too. And there's a company that's sponsored by Meta named Quansight also try to port many libraries to be compatible with free threading. So I think that maybe this is my personal expectation, not the official expectation, but maybe in 5 years maybe. So it's possible over 90%, but who knows? Like 10% will be paying for the free setting. So let's just take a look at. Yeah.
Yeah. Next is also a fun one. How do you align your CPython experience to your day job? So
yeah, so everybody asks me about the alignment with my day job and CPython, and the truth is that around only 10 people in CPython core team is full time for CPython core devs and core work, and the other members are doing a different thing. And I also did part of doing a different thing in my day work, but I set up the internal Python team that support the over company-wide issue that handling the Python. So at that time, like I collect the issue that what is happening in my company and what can I solve the problem. And some features, some features need to upstream, then I just ask to the Python core devs, so what if we provide this kind of feature? So that's how I make my alignment with my company and CPython work.
Next is, what are the prioritized or important topics in CPython at this moment besides free threading?
So besides means?
Like other than free threading.
Other than free threading.
Yeah, other topics.
Yeah, as I said, like maybe JIT. And one of the topic we discussed a few months ago is like how we clean up the roadmap of multiple experimentation project in this moment, like self-interpreter, JIT, free threading are experimenter. That the cleanup was one of the issue, and the other maybe non-technical, but important the issue in these days like about translation and documentation of Python language, because like we believe that we should provide enough resources that using the non-English users in their friendly language. So that is one of the rising topics about the translation topic that relates to translation. Yeah.
Yeah. As a side note, we also have a local translation team. Like you can reach out Matt for that, for translation into Chinese.
Yeah.
Yeah. So next, what do you think about the approach Mojo is taking?
Okay. So let's talk about Mojo.
So maybe I read the wrong one. So yeah. I would like to ask about the recent news that GitHub now report to Microsoft. So how do you think this change might affect the open source ecosystem?
Well, very surprisingly, the GitHub is very currently and past is very supportive to CPython. Like we migrate we called BPO bugs.python orgs in the past, but we are now using the GitHub issue tracker. But the one story that while we migrate the issue tracker, like also we launched the batch program that from bugs.python org to GitHub, we crashed down the GitHub. Yeah, so after that incident, like GitHub is directly communicating us, and they always ask us what kind of things is needed. So, like for example, like GitHub Actions, like everybody knows that the ARM GitHub Action is released quite recent days, but we already use the ARM GitHub Action already because of supporting with the GitHub team. So I think that our relation between core devs and GitHub will be keep sustained. So I don't think to worry about this issue.
Yeah. So what do you think about the approach that Mojo is taking?
Okay. So first of all, I really love Chris Rottner, and he's my hero in my undergrad student. But I think that my personal opinion is that I already saw this similar approach in the past, like Mojo. I think that even what's different between the Python and the Mojo, because like one just difference between Python and Mojo is taking care about the GPU scheduling in the language itself. So I think that the impact is limited in that can then Mojo show. So that's might be a negative comment, but I still love Chris Rottner, and I hope that he can do good things. Yeah.
Yeah. Next one. What motivated you to become a core developer and even a member of the steering council?
Yeah, so this is real true stories that like the first attempt that I nominate myself as the student council is like people is Python core team is very shy. They're shy. So like when you have a election of student council, like they just nominate just day before. So like. But like so I just like, oh, then if you don't want me, I elected as student council, like just please nominate yourself faster than just day before. So I just nominated 5 days ago before the elections. But after that, like I feel that like there's a reason that not many Python core devs is represent. Like for example, APAC is just maybe under 5 people stay in APAC region. So the problem is that like how I can share that the requirement or issue of the Python in a APAC region, because like in APAC, like there are many local tech company even if they are not huge as a Google, but they have their workload, because like my observation is that like good big tech company in US is like they care about the 24-hour service all around the world, but like Korea or Japan or Taiwan, maybe they are focused on their local event like Happy New Year event or Thanksgiving Day event. So so requirement is slightly different. So like so if I think that if I become a student council member, like I can share some issue that I observe in APAC regions. That's why my current motivation of why I'm working at student council. Yeah.
Next is also an interesting one. Why do we need a 5-person steering council to continue a single PDFL?
That I want to answer with like if you watch the documentary maybe one weeks ago that about the Python, and if you watch that episode about the wireless operator and Guido, like I know that the technical discussion always happen, and something is very heated, but like it is not good experience like that just one man should give our feedback, even the negative feedback in our days. So good things about Python steering council model is that we can think about the widely perspective that single person cannot know. And the other thing is that the people is communicate with the steering council, the group itself, not the personal. So even if we announce something about the path that has a controversial conversation, but nobody contacts someone in person, but just they discuss with the steering council. I think that's the way to protect the people in Python core team.
So what language feature do you hate and want to get rid of from Python? It's a tough one.
I love every module in a Python. So sorry, but I think that like what we want to focus on this day is like the era has changed when the Python is born. Like now its packaging is very easy to do that. Like but early 1991 or 1992, like network was not that advanced at this era. Like so we have many battery that are usable, but I think that we can make a little bit lightweight, and I think that these days the Python core team is trying to remove the modules that can be maintained by third-party library, because like because the issue that is we cannot keep everything updated for the newest spec in Python core team. So I think that's one way we are going to pursue these days.
So what do you recommend a person to do if he or she wants to contribute to CPython or even becoming a core developer? So yeah, my advice is first advice like just not to be urgent. Like just take at least 2 or 3 years, because like from the view of the Python core developer or as a committer, or maybe have the same idea that who maintain the popular open source project, many contributors actually jumping into the Python open source project and disappear. So we want to make up with people like keep going along years, like and discuss about a lot of things. So the first thing is that let's keep patience, like, and let's keep a long way, and make a credit with a simple issue rather than solving a too complex issue. Because like I know that everybody in here have a good ability to solve the problem, but like from our view is like we don't know he or she's background or what he did before. So like we want to see that person how he or she is understanding the workload that exists. So just to look at a simple problem at the first time, and then evolve your issue that can solve them more deeply. So that's my tip. And I know that this is not like maybe not you want, but that will be a solution. And last thing is like just to meet up people in a core team. Then because like we are person, like we are not just the people in online. Like so, if you communicate in online and offline, maybe you can make a rapport with him or with the people, and then you can discuss more deeply, and maybe people will help you. Yeah, a shameless advertisement. So we also had similar discussion in our podcast recording yesterday. So stay tuned for more explanation on it. Yeah. So what is the future of Python versioning, and will there be Python 4?
Sorry, I cannot answer because like I have to discuss with the Guido first. What's the Python 4? But like I just want to share that the important sentence from Guido is like the from Python 3 to Python 4 is not same as Python 2 to 3. Like it's more like Python 1 to Python 2, Python 1 from Python 2. So that will be a Python 4, but I don't know. Yeah, who will know? Maybe 10 years later? I'm not sure.
So what do you think we can do to increase the CPython involvement in the APAC area? And what do we really need to do, and why is that?
I think we can do increase the CPython. Yeah, as I said, like I know, but this is my observation bias that I observed the APAC engineer. It's also maybe especially Northeast Asia engineers. Like let's not just think about the CPython. Like if you meet the issue while using a popular framework like Fast API or Django, like if you make a trouble, what do you think? Like, do you think that your code is issue or the framework is not supportive or your workload? The answer is half-half. So sometimes like you wrote the wrong code, then in that case you should fix your code. But in some case, the framework does not cover your use case, because like the maintainer cannot observe every use case that exists. So one way is that like when you meet the issue in using a specific framework, even of CPython or popular framework, just report it. You need this. And I think that's my observation, that the Western engineers doing very well. But maybe it's unbalanced the existence of maintainer in a Western area and East area. But the important thing is that they should know. So don't just using the workaround, even if that there's a lack of support in a specific framework. Just reporting and talking with the maintainer. And I think that today is a very good time if you're using the Fast API in the workload.
Yeah, so some Python-related features are kind of replaced by Astra's products like UV and Rough. So what's your opinion on this?
Yeah, it's tough questions, because like it will be directly related to asking that what will be the relationship between UV and PIP. So I have no answer. I cannot comment on anything about this, but I believe that the Python packaging team and UV has a good relationship, and they going forward. So and I'm using the UV every day. So I hope that the project could be sustainable, even from the company approach or the Python packaging team side. So that's my answer.
Okay, so if anyone has questions, you are also welcome to ask live now. And also welcome to ask in Chinese, and I can do the kind of translation. Any questions? Please just raise your hand. Yeah, if no, you can also reach out to Donghee after the keynote offline. So I think this is the end of the keynote. Thanks. Let's give him another round of applause.
Thank you for listening.